Hello everyone, my name is M. Jagdish. I am from 2nd CSMA and my roll number is 234G1A3355. Today I am going to discuss about derive the mean and variance of the Poisson distribution, and the subject name is probability and statistics. Derive the mean and variance of the Poisson distribution. Introduction to the Poisson distribution. Let us briefly discuss about the Poisson distribution and explain the key properties. Event occurs randomly and independently over a fixed interval. State the probability mass function PMF. P of x is equals to k lambda to the power of k into e to the power of minus lambda whole divided by k factorial, where lambda is the average rate, highlighting its independence. Understanding the expectation E of x. Define the expectation E of x as the average value of a random variable. It is represents the center of this distribution. E of x is equals to summation of x into p of x is equals to small x acrossly all possibility values of x. Derive the mean E of x of the Poisson distribution is E of x is equals to summation of k into p of x is equals to k. Here k is equals to 0 to infinity, and substitute the E of x is equals to summation of e into lambda to the power of k and e to the power of minus lambda whole divided by k factorial from k is equals to 0. Simplify and adjust the summation index E of x is equals to lambda. The mean of the Poisson distribution is lambda. It is the average rate of the event. Understanding the variance of x, and define variance as a measure of spread around its mean. State the formula variance of x is equals to e into x square minus e of x whole square. Deriving e of x square from the Poisson distribution, rewrite e of x square as e of x into x minus 1 plus e of x, and e of x into x minus 1 is equals to summation of k into k minus 1 into p of x is equals to k from k is equals to 0 to infinity. Substitute the PMF, simplify and adjust index to start from k is equals to 2, and here e of x square is equals to lambda square plus lambda. Deriving the variance. Variance of x of the Poisson distribution. Substitute e of x square is equals to lambda square plus lambda and e of x is equals to lambda into the variance formula. Variance of x is equals to lambda square plus lambda minus lambda square. Simplify the equation. The variance of the Poisson distribution is lambda. Properties of the Poisson distribution. The Poisson distribution is defined for non-negative integers where lambda k is equals to 0, 1, 2 up to infinity. It is memoryless, meaning the occurrence of an event does not depend on the past occurrence. The distribution is skewed especially from small values of lambda, but becomes more symmetric as lambda increases. Applications of the Poisson distribution. The Poisson distribution is widely used for modeling rare events in various fields. Example including the number of phone calls at a call center or the number of decay events from radioactive sources. Understanding its mean and variance allows from better predictions and resources allocations. Limitations of the Poisson distribution. The Poisson distribution assumes event occurs independently and at a constant average rate. It may not be suitable for over displaced data where variance exceeds the mean. The real world data may require adjustments or alternative distributions if these assumptions are validated. Thank you for giving this opportunity.